Here's the latest study guide for the for photovoltaic system installers. This is actually, you can download it, it's for free on AppSet. You can print it, it's about 70, 80 pages. And you can, excuse me? Well, anyway, this is a study guide. You can download it for the system, you can print it. You can have your wife print it where she works, and then you can get it for free. All of this information, www.napset.org, and you can get all the information you want.
What's the website?
Napset.org. Just go to Google and you type NABCP, you're going to get all the information you need. It's very easy. How much simpler can I make it? Just go to Google, put those things up there, search for it, you're going to get everything you need. Believe me, you're going to spend hours looking at that information. All you have to have is the will to learn, and it's there for you. It's not easy, it's 77 pages, but if it's really written in a nice size of letters, it's probably about 200 pages. So does it have pictures? Yes, it has everything you need to know about the test.
Solar power for dummies.
Everything you need to know about the test. Okay, all the requirements up here. And even has some review questions for you guys to see. Okay, just a percentage, you can't see it all the way in the back, but just to know what's contained up there. Working safely with photovoltaic systems, 15% of the test. Conducting site assessment, about 5%. Then you need selecting a system design, 5%. Mechanical design, 15%. This is the part that they know. Electricians don't know much. So the electrical design, 20%. This is where you and I, or you and the inspector, fight around for all the stuff that you have done. The systems and the components associated with that, another 20%. Performance system checkout and inspection, another 10%, and maintaining, troubleshooting the system, another 10%. So there's actually a whole slew of questions that you have to consider. But again, a lot of it is working safely with a photovoltaic system. Okay, it's an excellent study guide. You can get it for nothing. It's published last year. And there actually they refer you to a lot of other references that you can search into to learn photovoltaic system. Trust me, if you go there, you'll find enough information that will keep you busy way past Super Bowl Sunday. Okay? Some of the stuff, actually a lot of the stuff I'm going to go over as we go through the process of the course, because we're going to be covering through them. And some of the stuff, it's pretty fundamental about fall protection, how to handle ladders, what kind of ladders, OSHA requirements, hand and power tools, GFCI protection, all kinds of personal protective equipment for hazards that you have to know, and a lot of the stuff associated with the actual electrical design. You got to understand, like I said before, this course, it goes from the bottom up. It's not like we're jumping up there and let's put the modules together, put them together and stick them in the inverter and so forth, and let's turn the system on. This is not the type of a course, and this is not really what the test is going to test you on. Okay, the electrical part is about 20% of the system. Most of you're going to find out when you actually do the electrical installation, it's not different than when you do an electrical service or a motor control. Once you know how to handle the actual calculations for sizing out the conduits, the wires, the temperature considerations associated with them, once you do 1, 2, 3, 4 of them, then you're really pretty good at it. Okay. One of the discussions we had before is actually, remember, and I'm making it a point in here, is whenever somebody is installing an electrical piece of equipment, you either have to be a licensed electrical contractor or working for a licensed electrical contractor. Don't confuse the issue just because if you're not an individual who works for a licensed contractor or is a electrical licensed contractor, you cannot be installing photovoltaic systems or systems associated with the photovoltaic system. Just keep that in mind. Just one other question, your question I answer. All right? So any questions about this examination, about the contents, about the course, and so forth? So let's go into okay. By the way, this is a great organization. This, like I said, for the photovoltaic industry, there's a lot of information that they collect and they make it available to you people, and they continuously update them. There is a, so I can close this discussion, there is an application that you have to fill in. There's a fee associated to it, and there's a fee associated to the examination. Okay. I believe the initial application is about $100, and I think the test is about $300. But again, these things can change. I'm not exact into that. Okay, let's go to chapter 2. Part of the chapter 1 was discussed last time in the class. I'll review it a little bit later on to give some idea. We're going to talk a little bit more about chapter 2, something about solar radiation. Let's see where all this energy comes from the sun and how we capture it, what some of the important things, some of the definitions. So actually, in this particular part of the presentations for today, we're going to describe what is solar radiation, solar radiance, something about the inverse square law, what that thing means. We're going to define and describe what we mean by solar irradiation. You hear a lot of those terms over and over again, and what do they mean? Something about solar constant, what the solar spectrum is consists on it, with respect to what is terrestrial and extraterrestrial radiation. One is below the in the atmosphere, and one is above the atmosphere. Some of the characteristics of radiations, direct and diffuse type of radiations. What is important? How they play into the actually in the photovoltaic systems. We'll talk a little bit about air mass effect and what does that do with respect to the amount of solar radiation that is presented. We'll define something that we call peak sun radiation, and something that we call it peak sun hours, and be able to determine how a particular photovoltaic system will perform in a different location in the country or a different location within an area. And we'll talk a little bit about something that's called insolation. This is most of the times the word that you're going to hear when we deal with the radiation things. Some of the types of spectral distributions for solar radiation, some of the devices that they use that we measure solar radiation. We talk about how the Earth is moving around it to see at what point in time we get the maximum and minimum radiation that comes from the sun, because we know that the Earth is spinning around the sun, and we know that the Earth is slightly tilted and so forth. A lot of the stuff you're going to hear once today, and that's it. Well, you got to hear it for some reason, okay? Some of the characteristics about solar time, as with respect to standard time, some of the positions on the sun at certain points in time, and we talk a little bit about the array orientations with respect to the sun and the different seasonal times. And we talk about where is some of that information about solar radiation. It's available, so we can actually pick up a book, find out, and say, okay, here I am. I'm in New Jersey, this particular area. This is how much sun I'm going to get. So we'll sort of take you back to third grade in grammar school. Then we'll take you a little bit in high school, then a little bit in college, and hopefully we'll settle down and say, okay, I had enough of these things. Just tell me what